Hello, my name is Benjamin Knapp, and I'm a faculty member in the School of Natural Resources at University of Missouri. And I'm also the superintendent of the Basket Wildlife Research and Education Center. And so as part of the Basket Center Virtual Field Day, I'm going to be giving a presentation today going over 50 years of forest succession across 4 forest types at the Basket Center. When we think about forests and how forests change through time, we have processes of new trees coming in to the forest through regeneration, growth of trees into larger sizes, and then the death of trees due to maturity and senescence or competition that goes on within that forest. These changes happen over a long period of time. So thinking about the patterns of change and what we're seeing in terms of forest development can help us think about reaching certain management objectives. And we have a lot of examples where the way forests have been changing over the past number of decades maybe are not matched up well with the management objectives that we often have for those forests. So there's been a lot of research on this topic. And these are just some examples of some papers that address this. But one major change that we see is that forests that are dominated by oak species, we're seeing some transitions where as new species regenerate and come into the forest, we're seeing more maples and ash and other species, potentially shifting away from the oak dominance of those forests. And then in the bottom right corner, that paper refers to eastern red cedar. And especially in the central and Midwest portion of the United States, we're seeing a lot of eastern red cedar move into forest areas, sort of encroach on those forests and potentially change the composition. Now, because forests change so slowly, one important tool that we have for looking at and quantifying these changes is what we call forest monitoring plots. These are often plots that we establish and maintain permanently. And so we put them in place and tag trees and have a certain area that we remeasure on a fixed interval. And so there's a series of plots. There's a number of plots across different forests in different places, and we can use those plots to look at how forests change through time. Now we consider this to be observational data, meaning that we're not doing an experiment, we're not manipulating the forest, but instead we're just taking repeated measurements to quantify the changes that we see. At the Basket Center in Ashland, Missouri, we have a network of forest monitoring plots that extend across the property, shown here by the green points on the map of the Basket Center. These were set up in 1968, and they were set up so that they could look at, with the idea of capturing the different forest types across the property, but also characteristics such as slope, aspect, and position on the landscape. In 1972, one of the early papers using these plots looked at the position and the species composition in these forests to classify them into 4 different forest types. So we call those the bottomland type, the dry ridge and slope forest type, the mesic slope, which is a higher productivity, and then a glade-like forest type. So on the map now, those are the same points, but they're color-coded by the appropriate forest type classification, meaning that there's different species composition, different factors affecting those forests. So we've got 4 forest types across Basket with these plots, and I'm going to give a brief description of each one in some short videos here. So this is a good example of one of the dry ridge and slope forest types. And so here we see quite a few big trees that are mostly oaks. And so we have a canopy layer that's dominated by oaks, a lot of white oak in the system, but also some red oaks, including northern red oak and black oak. Much of the midstory here is maple. We have a lot of sugar maple that's coming into the midstory layer and blocks a lot of light from coming to the forest floor. The forest floor itself, we have a mixture of some herbaceous plants as well as seedlings, most of which fall within groups such as ash as well as dogwood and some of the shade-tolerant species as well. Now the site itself is sloped, so we're on a back slope position. The soils tend to have a lot of rock in the soils, but they're very rocky, and they don't tend to hold a lot of moisture. The site is also on a western-facing aspect, so it gets a lot of sun exposure. So this type of site tends to be fairly dry, which is one reason that oaks do well here.
So here we are at a mesic slope forest type at the Basket Center, and here there's some subtle but important differences between this and the dry ridge and slope forest type. So this area is sloping, but it's facing north or east, so it's more of a protected condition. There's more shade and more moisture as well. And we see that in the tree species. We have some large northern red oak on the site, mixed in with white oak as well, but we also get larger sugar maple, and we get some species we don't see elsewhere, including basswood, and here we see more of the pawpaw in the understory. We also have some indicators of more mesic soils here with species like Christmas fern that we have in the understory. The site tends to be shadier, and we have more difficulty getting oak regeneration on this site type. So now we're at an example of a glade-like forest type that we have within the Rochow study. And so here, as we're looking around, we see we're on a pretty heavy slope, and we've got a lot of rock that's coming to the surface. And so on these sloped areas, some of that bedrock gets exposed, resulting in very shallow soils. Here we also have a lot of calcium and limestone in the soil, and so that favors species like chinkapin oak and sometimes blue ash in these areas. Because it's shallow soil, it's a fairly low productive site, so we have a pretty open canopy, and we tend to have a lot of light that comes through. In a lot of cases in these areas, over the past few decades, cedars have come in, and so we see an increasing amount of eastern red cedar mixed in with chinkapin oak like we see behind us, as well as some other species like black oak. So we've hiked down the slope to show you a bottomland forest type here at Basket. In this forest type, we're typically going to be around creeks or rivers, so we have a fairly flat topography, and we have a lot of water that moves through this area. And we can see an area where water could flow behind us, and then shortly over to the side is the larger creek. Soils here are rich. They tend to have a lot of accumulation of smaller soil particles. They hold moisture and nutrients well, and the tree species really change. So here we have a lot of black walnut that's very large and straight, as well as American sycamore, black maple, and shellbark hickory. We have elms and buckeyes in the understory, as well as spice bush. So a very different species composition, and we also tend to get very tall, straight trees here, which is quite different than what we see in the upland type of areas and the other forest types at Basket.
Okay, so with that overview of the forest types, we can then look a little bit at the sampling and the forest monitoring plots themselves. So across all those plots, or across those forest types, we have multiple plots within the Basket Center, each of which is a 1/5 acre in size. And in that 1/5 acre area, we measure and mark all the trees that are 4 inches at diameter or bigger. And so those can be tracked through time, and we can get an estimate of the changes in the composition and structure of the plots. We use a smaller plot that's within that larger plot, 1/10 acre in size, to measure smaller trees. Those we call in the mid-story, from 1 inch to 4 inches. Because the number of those trees is going to be greater, we sample in a smaller plot. And these have been measured in 1968 when the study was established, and then repeatedly in 82, 92, 2004, and most recently in 2016. So we're going to use information from those plots to look at how these forests have changed through time, thinking about the future forest and the condition. So a few ways that we very commonly look at forest structure would be through the number of trees that we see on the sites or in the forest, the basal area, and then the size of those trees. So I have those 3 graphs up here. And what we're seeing here, if we look at the figure on the left, is the number of trees through time, where we have year on the x-axis and number of trees per acre on the y. And we have this depicted for each of our 4 different forest types. Okay, so we have a couple patterns that emerge. Overall, we see a fairly consistent number of trees through time. If we look at the green line, which is the mesic slope plots, we see that that number hasn't changed much through time. We had around 150 trees per acre, and this is in the canopy, so these are 4 inches and greater, in 1968, and a similar number in 2016. The dry ridge and slope plots, we started with a bit over 200 trees per acre. This is the orange line, and we do see a downward trend where the number of trees in those those plots, those forests, is decreasing. And we'll talk about that in a moment. A slightly similar pattern in the bottomland, but not as pronounced. And then in the glade, we actually see an increase in the number of trees in those areas. So some slightly different patterns, and we'll come back to that. Now, basal area is what we very commonly use to talk about forest density. And this essentially is taking a measure of the tree area, the trunk of the trees, that's occurring within that stand or that forest. And so it's reported in square feet per acre. And so here, for all these lines, we do see an increasing trend through time. Now, the green and the red, and that's the mesic and bottomland, the most productive sites, in 1968 had a fairly high basal area. So at that point in time, these were already above 100 square feet per acre. And so they've increased a bit to above 120. Now, the dry ridge and slope was around 90 square feet per acre in 1968 and is currently around 110. And the glade-like areas started at the lowest density, around 70 square feet per acre. And that type of forest we expect to be more open. But through time, we've seen a pretty pronounced increase to where we're over 100 square feet per acre there. So in all cases, we're seeing that these stands are becoming more dense through time. And finally, if we think about the size of the tree, quadratic mean diameter is essentially average tree size. We can see here either this value has stayed about the same or has slightly increased. And in some cases, for the dry ridge and slope, gone from about 9 inches to maybe 11. So it's increased a fair amount in terms of the average tree. These kind of patterns are pretty expected for what we see as forests mature, where we get an increase in the tree size. So the canopy trees are getting bigger. As those trees get bigger, the basal area is increasing. But because there's going to be competition occurring, the number of trees may actually decrease. And it's usually going to be small trees that are succumbing to competition, that would be dying, and causing a decrease in the number of trees per acre, whereas the stand is actually increasing in density and overall tree size. So that's not necessarily a bad thing, but it is indicative of a stand maturing. So those patterns look like all four of these forest types are maturing. That kind of pattern is what we see across the basket center. So we'll talk a little bit about forest composition, and there's a lot going on this figure, so I'll kind of walk us through it. So let's start in the middle, and here we're looking at data for a dry ridge and slope forest type. And so what we have in the very center is what we call a diameter distribution. So here we have the size of the trees, the diameter at breast height, from around 5 to 30 inches. And then we see two lines. So the light gray is the 1968 diameter distribution. So this is showing the number of trees in each of these size classes. Okay, and the dark line is 2016. So we see in 1968, we had a lot more small diameter trees in that year than what we see in 2016. Okay, so there's a lot more of those small trees in 68 than 2016, whereas in 2016, around the 15 to 20 inch classes, we see that the 2016 stand has more trees than the 1968. What this is essentially showing us is that the trees that were smaller in 68 have moved into those larger size classes. It's also indicating growth and maturing of those forests. So that's very expected as well. But let's look at the composition. So on the left, we have 1968. And what we see here is our diameter distribution. So across the X, we have diameter. And then on the Y, now we have the relative abundance. So of all the trees in that size class, what percentage belongs to different species? So our legend is for sugar maple. And we're seeing that the proportion, the abundance of sugar maple is greatly increasing in small diameter classes. What used to be white oak is now becoming sugar maple in those areas, indicating a potential compositional shift. We'll look at the same figure for the mesic slope plots, and let's just focus on the 1968, the colored graph first. So here, again, the blue is sugar maple, the red is northern red oak, and the gray is white oak. And so we see, for the most part, for 10-inch trees and greater, we're seeing mostly northern red oak and white oak. within those areas. The smaller trees, we already have some sugar maple in the more mesic sites, and then we have a mixture of other species as well. But the big shift that's happened since 1968 is we've really seen a dominance of sugar maple come into the size classes up to about 12 inches, which is a pretty large tree. And so most of the smaller diameter trees, the trees that are entering into that forest, are sugar maple in that mesic slope forest type. Now finally, for our glade-like forest type, here the dark brown is chinkapin oak, the blue sugar maple, but the species of interest to kind of focus on would be the dark green, which is eastern red cedar. And in 1968, there was very little eastern red cedar within any of these glade-like areas, and this is the species that has really increased and encroached on some of those smaller diameter classes. Okay, so we're seeing an influx in the cedar on the sites. The last thing we'll look at in terms of data is the mid-story. And so these would be trees from 1 inch up to 4 inches. Okay, and so I've got at the top the different classes, the different sizes. So class 1 would be the smallest, class 2 would be a slightly larger size, et cetera. And so we can think about that from 1 being small, mid-story trees, up to 4 being larger. And essentially the patterns that we see match what the previous figures have shown. On the dry ridge and slope, the sugar maple started off as smaller mid-story trees in 68 and 82, and then in the more recent years have come into slightly larger classes. But a big thing to note with white oak is in 68, we did have some white oak in those mid-story positions, but in 2016, there's essentially none. So we have no white oak poised to replace that stand. A similar story in the mesic slope, where sugar maple again is in high numbers in those small classes. And in 2016, we have no white oak. And then in the glade-like areas, it's the same story with our eastern red cedar and our chinkapin oak. So kind of takeaways from this. Overall, the forests of Basket are showing trends of maturation. We're seeing increasing tree size, increasing forest density, and that's normal. Species composition is showing some slight shifts. In bottomland forests, I didn't really focus on that for composition as much because shifts aren't really occurring that are very strong with the species. But for the other areas, we're seeing sugar maple come into small size classes in the dry ridge and mesic slope, and we're seeing eastern red cedar come into those classes in the glade-like areas. And these are very common conditions, okay? And so we see that across different areas in the east and the central states, where sugar maple is a really big competitor, or red maple, for oak. And so we know that forest management can address this challenge. We can do different treatments, change the light regime, potentially use prescribed burning, or some control of those maples if we want to encourage oak regeneration and maintain an oak dominance in the future. In glade areas, we can increase the use of fire, use mechanical thinning of the cedars as well to open things up and get that highlight environment that really is characteristic of glades. At the Basket Center, we're acting on some of these management opportunities and looking at methods to effectively enhance some of these conditions. And we have a new study to look at oak regeneration success that a master's student is starting on now. So with that, I'll wrap up this presentation. If you'd like any more information, you can contact me, my email, phone number, and social media. And then the paper that most of this work is from, the most recent paper, is also shown there. So thank you.